This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. For over 2 years now, the Mars Perseverance rover has been gathering samples of Martian rocks, soil, and atmosphere for return to Earth on the Mars Sample Return Mission, or MSR. This mission is being managed by the Jet Propulsion Laboratory in California and will be one of the most ambitious campaigns ever attempted in space, bringing the first samples of Mars material safely back to Earth for detailed study. These samples could help scientists answer the question of whether ancient life ever arose on the red planet. Plans call for bringing samples of Mars to Earth in several steps with multiple spacecraft that could land on Mars, secure the sample tubes, launch them off the surface, and ferry them back to Earth. And yes, it's complicated. Here's a more detailed explanation from the Space Bucket.
Mars sample return is of fundamental strategic importance to NASA, U.S. leadership in planetary science, and international cooperation. On this mission, NASA and ESA, the European Space Agency, are planning ways to bring the first samples of Mars material back to Earth for detailed study. The Mars Perseverance rover is the first leg of this international interplanetary relay team. Its job is to collect and cache samples on Mars. Next, NASA's Sample Retrieval Lander would touch down on Mars and remain in place to receive a diverse collection of scientifically curated samples of Martian rock, already collected by NASA's Perseverance rover. The payload mass of the lander is double that of the Perseverance rover, 1,241 pounds or 563 kilograms. The lander's hefty cargo would include a rocket, sample transfer arm, and 2 helicopters. Each landing leg would be roughly the size of a human adult, with the whole lander standing over 6 feet tall or around 2 meters. You then have the sample recovery helicopters, which are modeled after the successful Ingenuity Mars helicopter. These specialized rotorcraft would be a secondary method of sample retrieval for the NASA ESA Mars Sample Return campaign. Currently, the Perseverance rover, which has already been collecting samples for the potential safe return to Earth, is planned as the primary method of delivering samples to the Sample Retrieval Lander. The sample recovery helicopters would expand on Ingenuity's design, adding wheels and gripping capabilities to pick up cached sample tubes left on the surface by Perseverance, and transport them to the Sample Retrieval Lander. Inside the lander is the Mars Ascent Vehicle, or MAV, a lightweight rocket that would transport the Sample Return Container, or Orbiting Sample, OS, into orbit. It would be the first rocket ever to launch off the surface of another planet, and would transport the sample tubes containing Martian rock and soil samples into orbit around Mars. The rocket and orbiting sample container would travel to Mars on board the Sample Retrieval Lander, and would remain on board until they've been loaded with samples and prepared for launch. After launch, the Earth Return Orbiter, or ERO, provided by ESA, would be the first interplanetary spacecraft to capture an object in orbit around another planet, and make a full round trip to Mars and back. It would also be the biggest ever spacecraft to orbit the red planet. The spacecraft would locate, intercept, and capture a volleyball-sized capsule launched from the surface of Mars. The entire campaign would be operated autonomously away from Earth at over 31 million miles, or about 50 million kilometers away. Once the orbiter has completed its rendezvous, it would perform a maneuver to capture the orbiting sample container within the NASA-provided capture, containment, and return system on board the orbiter. To do this, ERO would use high-performance cameras to detect the orbiting sample at over 620 miles or 1,000 kilometers distance. Once locked on, it will track it continuously using cameras and LiDARs throughout the rendezvous phase, all the way up to capture by CCRS. CCRS will sterilize the outer surface of the orbiting sample container and contain it safely within the Earth Entry System, EES. Having already spent 3 years to reach Mars and perform its support of surface operations by the lander, the orbiter would jettison major elements of the CCRS hardware, while still in orbit around Mars, to reduce mass before embarking on its 2-year journey back to Earth. About a week before arrival at Earth, and only after successfully completing a full system safety checkout, the spacecraft would be configured to perform the Earth return phase. When the orbiter is 3 days away from Earth, the EES would be released from the main spacecraft and fly a precision entry trajectory to a predetermined landing site. Once safely on the ground, the orbiting sample container with the precious Martian samples would be transported to a specialized sample handling facility, where they would be prepared for investigation by top scientists and laboratories from around the world.
The Mars Ascent Vehicle, or MAV, is being managed at Marshall Space Flight Center in Huntsville, Alabama, and is planned to launch in 2028 with the samples being returned to Earth in the early 2030s. As I said, this will be the first mission to return samples from another planet and will include the first autonomous launch from the surface of another planet. Exciting stuff indeed. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.